This is a prototype for the Atkinson Legacy PCB. And what the Atkinson Legacy PCB is it is a binary button game, but it's changed a little bit so that instead of having a screen and everything, we do everything through the serial monitor and through the DDB. So what this prototype is it's a 4-bit version of the binary game. On the actual Atkinson Legacy PCB, it will be 8 bits, but for simplicity of wiring and for proof of concept, I've chosen to do a 4-bit model. So what we've got here is we've got 4 buttons, and each of them is going to pins on port A. And these are all pulled up. And then we've got ground going to the other lead of these buttons. When these buttons are pushed, we have a low going to this pin on port A. Then, also on this pin, we've got an LED, and we've got the negative lead of the LED connected to this pin. That way, when we press the button, we have ground going to the negative lead of the LED, and the positive lead sitting in the positive rail. Therefore, when we press the button, the LED turns on. This allows us to see which buttons we're actually pressing and allows us to more easily add up our binary result. For example, if I just know the values of each button, we have 8, 4, and 1 summing to 13. Now, let's take a look at this thing actually working using the serial monitor. So now we have the game actually running in our serial monitor. And what we've got is welcome to the serial binary game starting. Your new number is 7. So on the binary button echo, if we make 7, which is 4, 2, and 1, we get your new score is 1 and your new number is 1. And each time we get the number correct using the binary button game, we get a point. So if I do 1, we get another point. Now our score is 2. Now let's do 9. 8 and 1, these LEDs turn on, and the score continues to count. So this just goes to show that it works. And the scoring system in this game is 1 point per correct answer. Now this should be changed in later developments, but the other thing is we've got the classic 1-minute timer, which can also be changed from 1 minute to any variation of time. The final PCB with the actual SMT assembly on it. And what we've got here is our headers that will allow this PCB to sit flush on the actual DDB-V8. And then here we've got our 8 buttons going from bit 0 to bit 7. And these are all connected to port A. Then here we've got our 1206 LEDs that indicate whether the button is being pushed or not. And then our 4 current limiting resistors on this side, and another 4 on this side, summing to a total of 8 for all 8 of our LEDs.